Okay. All right, so here we go. 7.2. So let's say you have a really tiny triangle.
What's the job?
Should have it, it's up front.
Go. Go.
Okay? You should have picked it up with the half slip.
I didn't even see it.
Look at, okay. So, similar polygons. You have similar polygons when corresponding angles are congruent. Corresponding angles are congruent. So, if I'm told it's a similar polygons, then I know that this angle and this angle are congruent because they're in the same spot. Corresponding. Here, then, these two are also congruent because they're in the same spot. They're corresponding. And then I can also say that the top two angles are congruent because I was told they were similar, or I wrote it down. Okay? Also, corresponding side lengths are proportional. Now I'll explain more about that in a minute. But not congruent. The corresponding sides are not congruent in similar polygons.
I don't think she spelled it wrong.
Okay? Oh, sometimes I do. No. Okay. Scale factor is the ratio of the lengths of the corresponding sides. So let's just say that this side is 2, and this side is 4, and this side is 3, and this side is 6. How much bigger is this triangle than this triangle?
Double.
Yeah, the sides are multiplied by 2, aren't they? So what's the scale factor for those corresponding sides? What number? Oh, so if Vinny isn't paying attention, nobody else will answer. Is that it? Come on, except for Allison. Okay, if we doubled this, 2 times 2 is 4, 3 times 2 is 6, what's the scale factor?
Double.
What number did we multiply by?
Double.
2. That's the scale factor, okay? Going from here to here. What's the scale factor from here, do you think? What was the scale factor on that table? What's the scale factor there? Supposed to be 1.2, see? All right, so, I know. Find the perimeter. All right, ladies and gentlemen, this is review. This is from chapter 5. The ratio of the length to the width is 4 to 3. So I'm going to write this down. Length to width is 4 to 3. You're going to set that equal to something to try and solve for x here. And you're going to set it equal to something to try and solve for x there. So take a minute and give that a try. If two polygons are similar, you're told they're similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. Okay? Let's work on this. List all pairs of congruent angles. Well, I don't want to list all the pairs. Let's just list some of them. So, if I'm talking about angle J, what's congruent to angle J? Angle N. How about angle L? What angle is congruent to angle L? Look at the picture. It's not that hard. Look at the picture. Angle Q. And so on. I'm not going to list them all. Okay. Now, what are the ratios of the corresponding sides in a write the ratios of the corresponding sides in a statement of proportionality. Okay, so if I'm talking about JK to NP, that's 2 over 3. Yeah?
Yep.
Okay, if I'm talking about KL to PQ, that's also 2 over 3. Look at that. Look at that. If I'm talking about LM to QR, 4 over 6, which reduces to what? 2 over 3. Put that on my desk, please. Okay? And then if that's true for those 3 corresponding sides, what do you think is true for the 4th one if we did the math? If we did 2.8 over 4.2, what do you think it reduces to? 2 over 3. Look at that. The ratios of each side, corresponding sides, are equal. Okay? All right, turn it over. Determine, this is how you're going to use it. Determine whether the triangles are similar. If they are similar, write a similarity statement to find the scale factor. Okay. If they're similar, all their angles are congruent, and the ratios of the corresponding sides are congruent. The ratios, not the sides themselves, but their ratios. Okay? So let's set this up and see. This side and this side correspond. So I'm going to say 10 over 15 reduced is 2 over 3. Now I'm going to I started with the small triangle on top, so I'm going to continue with that. 24 is to 36. 24 to 36. Look at that. That reduces to 2/3. So far we're on a roll. And then if I do 26 over 39, divide each by 13, I get 2/3. So, yes, I can say this. This is how you write it, and we've not talked about this yet. We're stating that these triangles are similar. Does anybody know the symbol for similar?
Yeah.
It's kind of just like a little sideways S. It's part of congruent, but it's not congruent. All right, that's all. It's just like, it's part of the congruent symbol, but it's not congruent, so you don't put that little equals there. It's just similar. All right, here they're telling us that these rectangles are similar. If they tell us they're similar, then their sides have the same ratio, correct? The corresponding ratios are equal. So I'm going to start with these two sides. I'm going to say 4:6 as 8 is to x. Because they told me they were similar, I can write this statement. The ratios of their corresponding sides have to be congruent. So then I'm going to cross multiply, and x equals 12. Bam.
We're done.
No. Okay, last one. A triangle work of art and the frame around it are similar triangles. Find the ratio of the length of one side of the art, length of one side of the art to the length of one side of the frame. So you put the art number on top of the frame number. That's what that 2 shows you. So this is the art, this is the frame. So 12 to 16. Art to frame. Reduced is a 3/4 ratio. Okay? Oh, wait a minute. Find the ratio of the perimeter of the art to the ratio of the perimeter of the frame. Huh?
What?
Wait a minute. How do I do that? I do that based on the theorem. What did the theorem say? If the two polygons are similar, then the ratio of the perimeters is equal to the ratio of the corresponding side lengths. So it's the same number.
Whoa. Check that out.
Voila.
Okay.